Good morning children. Continuing with the concept of cost curves. In the last session we talked about the total cost curves in the short run, and we talked about three types of total cost: total fixed cost, total variable cost, and summation of these two, that is the total cost curve. We also talked about the shapes of these three curves and the schedule of these three cost curves. Now in this session we are going to study about the average cost. We have already seen the classification of short-run cost curves. There are 7 short-run cost curves, that is the total cost curves, and then the average cost curve. 3 types of total cost curves were there, and now we have 4 types of curves left. 3 are average cost curve and the 7th is the margin cost curve. Now the average cost curves are like the similar class bifurcation of the total cost. Total fixed cost, similarly we have average fixed cost, then we have total variable cost. So from total variable cost we have average variable cost, and then we have the average total cost or average cost, that is from the total cost. The first and foremost that we will see is the average fixed cost. You can also see the schedule that is shown in the slide, and schedule is also an expansion of the previous one where you saw the total cost curves. Now you can see the average cost curves column also, average fixed cost, average variable cost, and average total cost, and also the marginal cost curves. We will be seeing them one by one. The first is average fixed cost curves. Now average fixed cost is the per unit cost of the fixed factors. You'll have to be careful about when you are studying, when you are listening to the video, be careful. Average fixed cost is the per unit cost of the fixed factors, and this can be derived by dividing the total fixed cost upon the number of units produced. So the formula is AFC is equal to TFC upon Q. This you can see in the table that average fixed cost in the first unit of production is equal to total fixed cost because nothing is subdivided. But as you move on to the second unit produced, what you see that average fixed cost is falling from 120 to it has become 160. So if you will put the values, that is TFC, that is 120 upon 2. So the overall average fixed cost will come equal to 60, and this is how you will be deriving the average fixed cost, TFC upon Q, right? Now and what we see that calculation, what we see that average fixed cost is falling throughout with an increase in output. And why this is so? Mathematically speaking, this is so because the total fixed cost, that is the numerator in our definition, then the definition says AFC is equal to TFC upon Q. So the numerator over here is TFC. So the numerator in our definition is spread over larger and larger units, that is the number of the denominator is what? The numerator in our definition is spread over larger, that is the denominator. So what we see that when you move on, the numerator is TFC and the denominator is number of units produced. So as the number, since total fixed cost is constant, when you keep on dividing it with further units of output produced, the average fixed cost will fall. This is what you can see, that when you divide TFC by Q, that is, suppose we can take the third unit. If you see third unit, at third unit of output, if TFC is constant 120, if you will be dividing 120 by 3, the average fixed cost will come to 40. But if you move on further and you can see the sixth unit, if you divide the same 120 cost, that is fixed and constant, with 6 units of output produced, it will come to 20 only. So mathematically we understand, technically we also understand that since total fixed cost is constant, as the number of units produced are increasing, the average fixed cost will fall, right? This is what is happening over here. Then second is the average variable cost. Now the average variable cost is the variable cost of the per unit cost of the variable factors of production. This can be obtained by dividing the total variable cost with the units of output. The way you have derived the total fixed cost, similarly you can derive the average variable cost also. That is the AVC is equal to TVC upon Q. Now you can see it mathematically in the schedule. If you see the third unit of AVC, it is showing 34 value. The value is 34. Now how you will be deriving it? TVC of the third unit is 102. If you will divide 102 by 3, you can have 34 over here, right? This is how you will be deriving AVC. Now the behavior of the average variable cost is derived from the behavior of total variable cost. So mathematically also since we are deriving the values of average cost curves from the total cost curve, so definitely the behavior will also be derived from the total cost curves, right? So this is what you can see graphically. We will be seeing it what happens. What we see over here in the table is that average variable cost first falls. So from first unit of production we see 40, then it starts to fall down 38, 34 and 33. So what we observe till fourth unit of output produced, the average variable cost is falling, and after that it has started to rise. So this is mathematical concept over here. We will be seeing graphically why or technically why this is happening, that we will be seeing in the diagrammatic part. Then we come to ATC, that is average total cost or average cost. Now like total cost is the summation of total fixed and total variable cost, similarly average total cost or average cost is the summation of average fixed and average variable cost. This can be derived both the ways, either by putting the formula AC is equal to TC upon Q, or you can have AC is equal to AFC plus AVC. Both the ways you can derive ATC or AC, right? So this is about, and the definition for AC is average total cost, or simply average cost is the per unit cost of both fixed and variable factors of production, and this can be obtained by dividing the total cost by total units of output. Since the total cost is the sum total of total fixed and total variable cost, average total cost can also be obtained as the sum total, as I told you that AC is equal to AFC plus AVC. So this is what we are saying, that this can also be obtained as the sum total of average fixed cost and average variable cost. Now this can also be shown in, this can also be seen in the table, where you see that ATC is obtained by adding values of column 5 and 6. For example, you can see when 3 units of the commodity are produced, average total cost is rupees 40, that is the average total cost is equal to rupees 74, that is rupees 40 plus rupees 34. So what we see, that the table, that the average total cost declines first, be careful, up to 5th unit and then rises after 5th unit. Now I will have to make a point over here that productivity and cost are the two sides of the same coin. What do you mean by that? I mean to say that if in terms of productivity, if the productivity is higher, that means the cost of production is low. So we are saying that productivity is higher. But if the productivity is low, that means it is aptly clear, if the productivity is low, that means in terms of cost it is high, right? So this thing we'll have to keep in mind in order to be very clear about the shape and the various fluctuations in the cost curves. Then the last curve in this entire section is the marginal cost curve. The moment this term marginal cost curves into our before us, so the word additional strikes to our mind, and that is what we are saying, that the concept of marginal cost, it is very fundamental, and marginal cost is the addition to the total cost as one more unit of output is produced. That I repeat myself, that marginal cost is the cost which is a change, which is an addition to total cost as one more unit of output is produced, or in other words we can say marginal cost is the addition to total cost of producing n units instead of n minus 1, right? And symbolically, or we can say formula, the MC of n is equal to TC of n minus TC of n minus 1. This formula you are using as an every now and then you are using this kind of formula for deriving the marginal concepts. In the utility concept you have already used this concept, right? And then in the production chapter you have already used this also, marginal productivity part also you have used, and here also marginal cost production also you are using the same formula, only the concept is changing, and so the formula, the application of the formula, the derivation will remain the same. So this is all about the theory part of the average and marginal cost curves. Now we come to the diagrammatic part and the relationship between all these cost curves. Alright children, you can see the figure, it is shown, the diagram is shown in the figure, and I will be explaining you the diagram. If you find any difficulty in drawing the diagram, you can let me know, I will be drawing the same for you individually. So the first curve that will be taking up in this diagram is AFC curve, that is average fixed cost curve. All the three curves are shown, the schedule is also there before you, and I've already dealt with you as far as your schedule is concerned, right? Now average fixed cost curve is the per unit cost of the fixed factors of production, and we have already talked about the derivation of this curve. Now the shape of the AFC curve is, it is sloping downward continuously, as you can see from the left to right. It shows a continuous fall in the value of average fixed cost with increase in output, that is shown in the table also, and that is the same is represented in the diagram also. Now this is because the TFC, that is the total fixed cost, remains the same at all levels of output. So when it is divided by the greater and greater output, that is what the formula is, in order to derive AFC you have to divide TFC upon quantity, right? So when TFC is constant and you are dividing the TFC by the greater and greater output, AFC falls. This is the technical reason behind it, right? And AFC curve is a rectangular hyperbola also in the shape, that is the curve which extends towards both the axes in an equal manner without touching either of them. This is what is there about the AFC curve. Now for the reason for this curve not touching both the axes is because it moves towards the y-axis, because the total fixed cost has a positive value at very low levels of output also. So this can never be 0. The curve approaches the x-axis also, but it is not touching that axis also, because the average fixed cost cannot be 0 since the total fixed cost is positive at all levels of production. This is the reason that is, even though it is asymptotic curve, it is rectangular hyperbola, and this is the reason behind this all. Then we come to the AC curve, that is the ATC curve or AC curve. This is the same, average total cost or average cost is the same. Now average cost curve will always lie above the AVC curve, as you can see in the diagram. Actually ATC curve or AC curve is lying above all the curves. Why? Because ATC or AC is the summation of both AFC and AVC. So it is lying above the AVC curve at all levels of output. Now AVC, now the technical part of these curves is that AVC, that is the average payable cost curve. You will have to be careful about the diagram over here, that average payable cost curve reaches its minimum point, which is in your book A. According to your book, the minimum point of AVC is A, where AFC and AVC are intersecting each other. This minimum point on AVC is at a lower level of output than that of AC, which is at Q3. What you see in the diagram, that the minimum point of AVC A and minimum point of AC is B, and the level of output of minimum point of AVC is Q2 and minimum point of ATC or AC is Q3. So what we are saying that ABC reaches its minimum point at a level of output lower than that of AC, right? Because when ABC at its minimum point, AC is still falling because of falling AFC. Mind you that AC or ATC is the summation of AFC and ABC, so it has influence of both the curves. But here the reflection of AC, that is the minimum point of AC reaching later than the ABC is, because AFC is still falling. So that is what it is, the reason for it. So as the output increases, the gap, the next thing that you see over here, that as the output increases, the gap between the AC and ABC curves decreases. That is what you can see. But they never intersect each other. It happens because the vertical distance between them, that is AFC, that is the distance between ATC and ABC. You can see the line over there, the arrow that is showing AFC. So the distance between ATC and ABC is equal to AFC. So even though these curves are moving closer to each other, but they will never coincide or never intersect, because the distance is equal to AFC, which is a positive value. All right. So which can never be 0. This is about the diagram. Now there are certain things also that we will be seeing over here, that the shape of the ABC curve is U-shaped, right? You can see over here, you can say that the shape of the, it's not a complete U, identical U is not there, but we say that the shape of ABC curve is U-shaped. Now why do we say that the shape of the ABC curve is U-shaped? Now first and foremost thing that we say, the reason that the logic that we give behind this explanation is that ABC curve is U-shaped due to the law of variable proportion. Now if you remember law of variable proportion, the law of variable proportion says that as you increase the amount of variable factor over the given amount of fixed factor, the total product increases at an increasing rate initially and then increasing at a decreasing rate, and ultimately it diminishes. This is the statement for the law of variable proportion. Now I told you this also, that productivity and cost, they are the two sides of the same coin. What do you mean by that? It means that if you say that productivity is higher or the production is higher, that is what you say in law of variable proportion at early levels of production, that total product is increasing at an increasing rate. That means in terms of cost, the cost is initially it is increasing at a diminishing rate, right? That is what we are associating, that the U shape of the ABC curve is because of the law of variable proportion, that is ABC is negatively sloped over the early levels of output, because initially the technical reason, the law is that initially there is too little of variable input in comparison to the fixed input. That is, if you remember, you had 5 machines and you started with one variable factor only. So too many fixed factor in relation to variable factor is applied, leading to underutilization of fixed input. That was there, the reason for the U shape of the ABC curve. Then gradually as the variable input increases, you increase the amount of variable factor, fixed spec factors are better utilized, resulting in increase in efficiency of variable factor. That is, division of labor and specialization further adds to their efficiency, and all these factors, they lead to increasing returns. Hence ABC slopes downward in the beginning. These are the reasons for the U shape of the ABC curve. Then in the later stages, when it has started to rise, in the later stages of production, as the quantity of variable factors are increased in comparison to the fixed factor, the efficiency of the variable factor declines. Why? Because the variable factors have become too many. That is the overcrowding. The reason given in your book is overcrowding. Indivisibilities leading to diminishing returns to average variable cost curve, and so the average variable cost curve becomes positively sloped. So these are the reasons for the average variable cost curve to be a U-shaped curve. And then ABC falls up to optimum level of output due to increasing returns and rises due to diminishing returns to a variable factor. So this is the reason for ABC curve to be U-shaped. So we have talked about the ABC, AC and AFC curves, the shape of these curves also. You can go through the book also, and if you find any difficulty you can ask me again. I will be explaining the same to you again. Then there are certain observations that I have told you in your book. I will be dealing them also. Now they say the distance between the average total cost and average variable cost curve gets smaller as production increases. These are the 3 points in your book, right? That is what you can see. Now ATC curve is far above the ABC curve at early levels of production because the average fixed cost is a high percentage of the average total cost. But ATC curve tends to come closer to ABC at higher levels of output because the average fixed cost accounts for a relatively small percentage of the average total cost. This is the reason for these curves to be farther from each other at the early levels of production and coming closer at the later stages of production. Then second thing is that ATC curve is U-shaped, indicating that the average total cost falls initially, reaches the minimum point and then starts rising. Now these are the reasons for the shape of the curve. So you will have to be specific, particular about each and every curve and their shape and the reason for the every curve such shape. Now the level of output at which average cost is minimum is known as the optimum point of production, right? So for average cost to be minimum is the point A in your book, I suppose. Point B is given in your book where the average cost is minimum. Now ATC curve is U-shaped for the same reason for which ABC, that is the law of variable proportion, and then the minimum point on ATC curve is reached corresponding to a larger output. I have already dealt with this point, that is OQ3. Then the minimum point on ABC curve, that is OQ2. That is minimum point on ATC curve lies to the right of the minimum point on ABC curve. This is from the table, that is where minimum average total cost corresponds to 5 units of output is as compared to minimum average variable cost, which is at 4 units of output. This is the reason for the minimum for the different variating minimum points on ABC and ATC curve. So the next part is the marginal cost. Marginal, already you know the concept. Marginal cost, that is the additional cost. Now marginal cost curve is also U-shaped. The diagram is given. It is very simple. It is also U-shaped. You can see over here. Now for marginal cost we have to see certain things, that marginal cost has nothing to do with the fixed cost. We have talked about it in the total concept also, that marginal cost is the cost of the additional factor of production. Now in the short run, fixed factors cannot be changed, the amount of fixed factors cannot be changed, so addition is only made in terms of variable factor, and that is why we say that marginal cost has nothing to do with the fixed factors or fixed cost, and that the marginal cost is an addition to the total cost when one additional unit of output is produced, right? Then the second thing about marginal cost is the same marginal cost is associated with the total variable cost and total cost, because you are adding to the total cost is the summation of fixed cost and variable cost. So even though marginal cost has nothing to do with the fixed cost, but certainly it is associated with the variable cost and so to the total cost. This is easy to explain, since total cost exceeds the total variable cost by a constant amount, that is the amount of total fixed cost. The addition in total cost for one additional unit of output would be the same as addition in the total variable cost. So marginal cost curve derived from TVC curve is the same as derived from TC curve. Therefore MC curve is common both to ABC curve and ATC curve. And what you notice that the MC curve cuts the ATC curve and AVC curve at their minimum point. Now this can be shown in the diagram. This diagram is shown to you. You can see the diagram again. It is more or less, it is the same, only marginal cost curve has been added to it. And fixed cost curve is not over there, it is removed from the diagram. And what you see that marginal cost curve is intersecting the average cost curves from below. For this I will be explaining the reason to you. Then third thing about marginal cost curve, that is the shape of the curve. Is again it is U-shaped. As output increases, MC curve slopes downward, reaching the minimum, and then start sloping upward beyond OQ level of output, that is shown in the figure. The U shape of marginal cost curve is because of the again law of variable proportion. It is negatively sloped in the initial stages of production due to increasing returns to variable factor, and positively sloped thereafter due to decreasing returns to the variable factor. Now one thing more that is over here in the book, it is important to note that the TVC can be computed, can be derived, can be calculated as a sum total of MC of variant units of output. This is all I have already dealt with you in the utility. The concept of M is the same everywhere, and the derivation is also, the application is also same everywhere. So I will not be going in detail over it. This is all about the relationship and the marginal cost curve. Then the next thing that we will be taking up is the relationship between average cost and marginal cost curves, right?